Yes. So
All right.
dan hebben we die.
All right. I think we can almost start the webinar. I think we are a few attendees shy, so we'll give it a few more minutes until we let Dennis take the floor.
Yeah, indeed. We're almost good to go. We should have like a waiting music, if you ask me. Like in a Christmas vibe, Mariah Carey style.
Don't you have a playlist, Dennis?
Alexander is the host. He should have one.
All right, let's see.
Let me see. Hey.
There you go.
Oh yeah.
Beautiful.
All right.
Let me see. I have some video problems. Let me leave and come back.
This is a good start.
The thing is, I cannot hear anyone say anything anymore.
Should we start at like 10 past?
Yeah, 10 past 6 is all right.
Yeah. Okay.
Right.
Let's keep it at that time.
Right.
Het kijk je moeilijk, Erik.
Ik zit door de attendees te kijken. Wie het allemaal zijn.
Ja, dat is de interessante tussen. User, dat is de meest interessante.
Yep.
Ja, altijd leuk hoor. Die anonieme.
Ze kunnen ons horen, toch? Dus niet al te veel gaan roddelen nu.
Nee, precies.
Nee, dat is waar, dat is waar.
Het schommelt nog wel een beetje, de attendees.
Ja, ik zie het, ja. Beetje tussen de
Wel
10
beter. Ja.
en de 16. Kan je ook zien hoeveel mensen kijken op YouTube, of niet? Nou, 7.
Let me check.
20 man, als het gewoon een zaaltje zou zijn. Dus de moeite waard.
Ja, nou ja. Mhm. So, almost getting time to start. Going to start sharing my screen. It's time
Yes,
to
I
start.
think it's the best thing to start. One little thing more before we start. Welcome everyone to our first Spielberg webinar. And first of all, I'd like to thank Dennis and Eric for preparing an interesting webinar this evening regarding innovative design systems. I would like to ask you all to send your questions through the chat and number the importance of your question from 1 to 5.
That seems clear. I think then it's time for me to start now. Then I will kick off. I'm going to tell you guys about, I think it has already been clear, about the design systems. But first of all, who am I? I am Dennis Kirkneet. I'm a software developer at Bol.com. I'm a full stack developer there, so I do a front end and back end basically. But I do have a little preference for front end. I'm more of a front ender than a back ender. But I guess everyone has like a small preference for it. Something about my personal. I live in the Netherlands, southwest of the Netherlands, province of Zeeland. Next to that, I'm a snowboarder. I love to snowboard, and I'm a beer brewer. I love to brew beer. Alexander, can you tell you everything about my beers? I think we already tried it. I'm not certain actually, but if not, Eric can tell you about it. But that's about it about me. What am I going to tell you about this is basically what I'm going to tell you. I'm going to tell you about what a design system is, why a design system would fit your company, and I'm going to tell you something about Stencil. Stencil is basically the tool I'm going to make a design system with. And after, I will give you a demo about how I built a design system. So we just give a small demo, and I'm going to show you a few other solutions next to Stencil. First of all, what is a design system? A design system is basically a component library. It is a library filled with reusable web components. I'm going to keep with the definition of a web component that is basically a custom HTML element. It's kind of a loaded word at the moment, web component. So I'm going to stick to the definition of custom HTML component. The library is a shared library, so it can be used among other teams within the company. And that's basically in a shorthand what the design system is. And why would you want to have a design system? These are a few advantages. Basically, you will end up having less duplicate code. I've seen at a lot of companies where there were no design system yet, that basically there was double amount of work done. For example, a wizard where you can see the status of going through a process has been developed a few times, one by another team, one by a different team, and basically they could have been the same. It can sometimes help component testing. I've seen a few solutions where basically the state of a unit test is being used to build a design system, and that's kind of also a solution to it. If you have a good design system, it helps the planning of a sprint, because you are able to see which components you have and which component still has to be developed. So it gives a better estimate of how long a story would take to develop. The ultimate goal, if you ask me, of a design system is basically consistency. It is more user-friendly to have components which are consistent among your whole application. For example, back to the wizards example, that you have in a my environment where a user would log in, would see different wizards than in an open environment. That's not what you want. You will basically just one consistent UI for the user. For this demo, I'm going to make use of Stencil. Stencil is basically a tool chain to make scalable design systems. And now it's basically demo time. What I'm going to show you during the demo is how I built a design system. So basically a shareable component library. And I'm going to implement it for a fictional application. For in this example, Spielberg Coffee, which is going to show you like coffee sales of Spielberg Coffee. It's just a fictional company, but it's nice for this sample. First of all, I'm going to show you about the Spielberg design system. This is at the moment there are two components inside it. A button which I've called Spill Button and Spill Graph. These are, I can show it actually. They are also referenced in index.html, so you can basically see this component. I'm going to add in this demo a new component to this. You see there's just a button and a graph inside this, and I'm going to add a pie chart to it. I've already prepared it actually, so I just have to copy paste it inside. And now I've put it inside there. And I'm going to, this is quite simple example. This is just the class. It has an init, initialization, a function component will load. This is basically required for Angular. I'm going to implement it later on in Angular application, so that's why I've added that function. And it has a render where it just as an h1 tag with a div with a pie chart in it. In the CSS, I've made some styling for the pie chart, and I'm going to put this in the index.html. I can basically just use the back as declared here in basically in the component decorator. And I can just build this, and then I should be able to use that. Building is also needed to publish it, because then it will be built in your dist folder, which I'm going to publish later on to the npm repository. As you can see, there's the Pi coffee chart with just some sample in it. And now I am going to publish it to the npm repository. For that, I just need to version this up. Of course, you can make a nice script to automate it, but for the demo's sake, I didn't. Publish it. Now it will be deployed into the npm repository. It is deployed, and then I will go to the Spielberg coffee repository. This is basically an Angular repository. Yeah, I just used an Angular. I mean, I'm a bit of an Angular guy, but that's basically just having to use it in your component. Basically, having a reference is enough for it. And I'm now going to import the pie chart. I'm a bit lazy, so I'm going to. I do have to do npm install actually. Almost forgot one step. In the package JSON, it's been defined with an X, so it uses the latest version of the library. This is, yeah, it's already published, so I'm able to use it like this. Yeah, there it's suggested. Oh, it's imported. I'm able to use it in a component. I can just do it like this. Now I got it in there, and I'm able to use npm print start, which just does ng serve. It's a little slow, I see. It's coming. It's compiling. Time for a bit of water. Yeah, it's built successfully. And this is basically the Spielberg coffee application, where you can see the components which I've used, which I've made with stencil. You see the Spiel graph, which is displayed here. Spiel button. You can of course also give parameters with it. For the button, I've used it. The button text get report, which you see here. The button type primary, but that's more related to CSS in the component itself. The Pi, which is just some demo data in it, like this. So that's basically a small demo of how it works. And then I will go back to the presentation. And I'm going to talk a bit about other solutions to build a design system like this. At other companies, I have seen this solution. UiJar has been used at Telfort. It's quite kind of a good solution. It uses the state of a component in a unit test. So basically, if you make unit tests for your component, then it just uses the state it renders in, and then you can see that in a nice visual design, and you can just use it like that. At Bol.com, they use Storybook for the design system. They are currently building it with that, so it's not like fully finished yet. So they are building based on Storybook. And if you just have like an Angular environment, then you can either just use Angular playgrounds to play a bit with your components. It's also a very good solution, but it's just very Angular specific. So yeah. that's about it for my presentation. So it's time for the questions now. I'm quite certain there will be a few questions.
There was a question regarding the definitions of design systems.
Okay.
That there are more than just a component library, including copywriting, boilerplates, art direction, instructions, etc. Have you worked with other definitions of design systems already?
No, not quite actually, but I do know there are a lot of definitions of design systems. For some of them it's just a component. For some of them it's just a component library. For some of them it is just a library of for the UX guys where see which components are available. But this is kind of the definition I have seen before.
Okay. Then another question: would you recommend to use design systems for a startup?
Using it for a startup could actually be a bit overkill, but I would say that preparing to be able to use a design system later on would be a good thing. If you just have specific components which you can just later on publish to an NPM repository for later on to use it for other teams, could be a nice preparation for it.
Okay. So there's another one from Yannick Kleibau. Can you make your components agnostic of Angular?
What do you actually mean with agnostic in this case?
Yannick, could you explain? Yannick, I've just allowed you to speak.
Okay, do you hear me?
Yeah.
Yeah, I hear you.
So in the example shown, I saw that in the component there was some method implemented specifically for Angular.
It is not specific to Angular. Stencil, yes, works with either with any front end actually. It is just plain custom HTML which can be used in any repo actually. I've just used Angular as an example. The Spielberg design repo which I've showed you is just a plain repo, and the coffee repo was an Angular repo in this case. And there's also a question. Did I answer your question, Yannick?
Yeah, it was merely, can you make your component use in like an Angular and like React, or is this like too far-fetched?
Yeah, you can just use it in any framework you would like, or library you like, or a front that you like. I see there are more questions coming. Do you always have to push versions to NPM while doing dev? No, you don't have to push your versions to NPM while doing development. You can just import it with basically as a sub-repo to your project, so you don't actually have to publish it to the NPM every time. But if you're actively developing your design system, I would actually recommend it, because then you won't have to publish it every time. But if it is quite far in development, then you don't touch it that often. So then I wouldn't recommend to do that, and just make a separate repo and then develop what you need, and then come back to it and then publish it and then use it later on. And there's also a question from Eric. Custom HTML elements are not controversial, but I do see different definitions of web components sometimes, and I just wanted to use like a custom HTML element as a definition of a web component in this case. Let me see what the more questions are. I see one from Tommy Lee of the limitation of an npm repository, but basically there's no limitation of publishing it to only npm. You can also publish it to an Artifactory or whatever, but it requires a bit more configuration, and that's okay to do it because you only have to do it once anyway. But yeah, I just chose an npm for demo, which makes it easy because it's kind of out of the box. And I also see one more question from Joris Rieter. Is it possible to nest components? Yes, it is. Yeah, why not? I actually could see many good reasons to do that actually, and why wouldn't you do it? You can just use the same text inside a component and reuse it like that. Is there any more questions coming? Do you see any more questions coming, Alexander?
I see one from Erik Verboom. Why are custom HTML elements controversial?
Oh, I've already answered that. I said they are not controversial, but web components sometimes have different definitions within company, and I just wanted to stick to one definition, which is a custom HTML element. That's why I kind of said it. Did I miss any questions, Alexander? I don't think so.
I don't see any more questions at the moment now.
I actually think then it's if there are any more questions, feel free to email. You can just reach me, and you know what Alexander address is. You can forward it to me. Is it to show something from Bol? No, it's not possible to show something from Bol.com. I'm not allowed to do that. I did ask it actually, but I'm only able to say what they are. I'm limited to say what they are using. I'm not allowed to say versions of whatsoever. I'm just allowed to keep it at this. Actually, a good question. Then I think it's a good timing to go to Erik.
Yes. Hi.
Hi, Erik.
Hello. I cannot show my video because the host has disabled it. But start my video. There we go. Yes. All right. Good evening. Welcome. Let's show screen. Host has disabled my screen. Please, may I share my screen? Yeah, here we go. PowerPoint. Share. There we go. Everything visible? I don't hear anything, so I assume that's a yes.
Yeah, it's visible.
All right, perfect. Welcome. Good evening, everybody. My name is Erik Verboom. I've been working as a Python developer for, I think, 4 years now, approximately. Before that, I've been working different languages in PHP and in Java, and even a bit in C a long time ago. And tonight I will give a talk about developing a web application in Python primarily, but a lot of the concepts that I will show are applicable to any other backend language as well. It will be a bit more of a high over Flight, I don't have any demo prepared, and that's simply because well, I feel that it's a very wide range to cover, and I want to touch up on a lot of things. But of course, then you sacrifice a bit of the detail. So first, I'll try to work my way basically away from the front end that Dennis has just talked about over the API, the application programming interface, to the backend, where we store all our data, and then from there on we go to like the different applications that you can use for data processing, data engineering, data science as it's called nowadays. And after that, I'll talk a little bit about why to use Python instead of Java, PHP, C, well, any other language basically that's out there. In contrast to the front end, there's plenty in the back end. So let's get started. An API. Basically, the API is the interface of our application, and it's used to deliver our data to the front end or any other application that wants to use our data. It should be, well, simple and structured, so that, well, our data is, our users can get the data that they want easily and quickly. And most importantly, it can be, it should be easy to implement in the front end as well as in the back end, because, well, a lot of developers like to, well, build a beautiful front end or build a beautiful and scalable and performant database. But, well, designing just an interface to send your data over, well, at least most developers that I have seen, well, tend to like to skip that. So let's get to it. The first, well, the classical solution for an API is the REST API, RESTful API called. It stands for representational state transfer. And it's basically, it's very close to HTTP methods. So you can get entities, you can post updates, you can put new entities, and you can delete entities. It also stays often very close to the database structure. So, well, in a traditional relational database, you'll have, for example, as here below in a couple of links, you would have a table of products, and then in a REST API, you can go to your website /products, and you get a list of all the products, or at least all that you're allowed to see. And if you type products / the ID of one specific product, then you can get to see that product, and you get to, well, update it or delete it. So that way it's kind of closely integrated to well, both each HTTP and database. And the content type is usually JSON, but it can actually be anything else as you want. But I would suggest to use JSON nowadays. So that's the REST APIs. A newer and well, let's put it more fancy solution would be graphical, with graphical GraphQL. I'm not entirely sure what the official name is, but this is a query language that is developed by Facebook to be able to access their APIs, and it's more of a high-level language. I put some examples here. And you can see that, well, we want to find the good coffee. So we write a query for our good coffee, and we want to be able to specify from which origin that coffee should be. So we query our list of products. We want to filter it for coffee, and we want to filter it for origin as well. And then when we have our product, what we need to or what we want to query is the ID and the name, and we want to see the origin of the coffee. And since the origin is probably stored in a different table with its own properties, from that origin we want the continent and country in this case. And on the right side you'll see what we will get back from the database. And one very nice thing about Graphical is that you see that the structure of the data that we get back will always be exactly the same as our query. So that makes implementation on the front end side extremely easy. And very clear. So basically you get back exactly what you write. This in contrast to, for example, a REST API where you would ask for a product, but you would get a product with probably its origin and whatever else you ask for. It is worth mentioning that Graphical has been developed with a graph data model in mind, as opposed to like a traditional database tables. This because for Facebook this makes a lot of sense. And what is a graph data model? I have a quick schema here. So basically, instead of a list of users, you have like one user, and or you have a number of nodes. In this case, a user and a number of edges. So this user has sent a message and has received a message, and each edge leads to a different node. In this case, an email. And yeah, Graphical is not limited to graph data models, as you can see in this quick example. But in a lot of third-party libraries, you'll see that especially the nomenclature of edges and nodes is by default used. And it can be a bit confusing if you're not used to it. But if you know what it is, it actually can be very helpful. And indeed, like the last thing that I want to mention, it is dependent on third-party libraries. So on the server side, you'll need an interpreter of this query language, and then a translation layer to your database. And yeah, it depends. This was firstly developed for JavaScript in a JavaScript environment, so JavaScript frontend and Node.js backend. And I can tell from experience that the Python backend, at least the one that connects it to a Django application, is still very much work in progress. Usable, but buggy and not that well documented at times. So, well, that's definitely something to take into account while you're choosing your frameworks for your web application. Yeah, that's it about graphical APIs. I'll continue to the backend. The backend, well, generally has the job to store the data, store it in a way that it's accessible to all our clients, all our users via the API. It will typically hold, a database, in most cases, a relational database like Postgres or MySQL or MS SQL. Well, a lot of different options. There can also be MongoDB, called after the humongous amounts of data that it's supposed to be able to handle. It's slightly less structured than SQL. Yeah, for the backend, there are a lot of frameworks that make backend development, especially in combination with the REST API, very easy, even up to a point where it's mostly configuring your or defining your data model. And then you have Django and the Django REST framework to basically create your API mostly automatically. So that's very nice. And of course, the important thing of a backend is performance and scalability. So it should work well for our coffee startup now that we're selling like 10 cups of coffee a day. But it should also work well next year when we're selling 100 or 1,000 or 1,000,000 cups of coffee a day. Ideally, you would not need to touch the code of the backend anymore, which is of course questionable if that's realistic. But well, anyway. And last but definitely not least, the backend should keep your data safe. So it should easily make all your data accessible to the persons or the users who are allowed to see it, but should not leak it to anybody else. So then you get user management, how do you say, roles. That all should be handled by the backend, authentication, authorization. That's all the responsibility of a good backend. But I would like to go on because now we're getting to the fun stuff. The data processing, which actually, yeah, this is kind of the wild card. So backend is specific, an API, well, is something very specific, but data processing can be anything from calculations, statistics. Well, you have a lot of ETL pipelines these days, can be machine learning. Well, you name it, it could be it. And for me, as somebody who came into this in kind of a learning by doing approach, my first question was like, well, why not keep this in the backend? I mean, it's clear that you need the front end on the client side and the backend on the server. But since you have a server, why not use that same server to run also all your data processing tasks on? And there are a couple of good reasons not to, and a couple of good reasons to put your data processing in a separate application that will just contact your backend via an API as well. And I think the first one is, well, more principally, it's a different task. So the backend is responsible for making data available to the right persons and quickly. And the data processing is, well, basically taking data and doing something to it and probably storing it afterwards again. So those are quite significantly different areas of focus. And well, from there you can say in the famous Linux ideal, build software that does one thing and that does one thing well. So this data processing is something else than the backend, so it should be in a different application. A more pragmatic reason with the same result is, well, this data processing often needs some very specific expertise. So there are a lot of people that are not IT experts, that didn't do their masters in computer science, but that are, for example, engineers, data engineers, mathematicians, scientists, that, well, learn to code a little bit, and well, it turns out that Python isn't that difficult, and so now they start to build their first Python application. But you wouldn't want those people necessarily to be working on an application that also has your user database with all the usernames and passwords in it that might accidentally get leaked somewhere. So that's another good reason to, well, separate it. And the third one is calculation time. In the backend, I said before, well, data should be available quickly. A front end usually wants backends or wants a response within, well, 10 seconds max, better like 2 to 3 seconds, and calculations can take well, minutes, hours, days, depending on the application. So then it's good to have that on a separate computer, have that separate computer run its CPUs high and hot, and keep the backend available for all kinds of other stuff. So yeah, that all together, well, put it in a different application. You have your backend, you have your API, and have your data processing talk to your API of your backend if it needs data from there or if it wants to put data back. Let's look at some, well, frequent tasks in the domain of data processing. You can often see reports. A very, well, simple question in our example of the coffee is, well, how much coffee did you sell this week, this month, this year? And like sort of a situation that I have encountered repeatedly in the past is, well, you get one colleague in the startup who is very motivated, who creates an Excel file and, well, maybe every day dumps, takes a dump of the database of the sales of the day, puts it in Excel and does some calculations on it. We'll get good results. And it appears to be very useful. And well, as the company grows, the project grows, more colleagues come to it, and well, everybody wants to be able to do this calculation. So then like 5 more colleagues come, and they will soon say like, hey, I like your Excel, but I think I can do it better. Make some changes to it, and then the 3rd colleague makes more changes to it, and so very soon you'll have well, 20 different versions of that same Excel with all different results, and you don't know which one is the right one. And well, that's the time to start to think about how to do this in a more professional way. And Python scripts are a good solution to that, because well, you can use, for example, pandas to dump your database in. You can do all the calculations with pandas in a very performant way. You can use matplotlib, for example, for making your plots. And most importantly, what Excel doesn't offer is you can put Python scripts in a repository, put it on GitHub or GitLab or anywhere else, put it under version control, and organize the chaos that the Excel files led to. And finally, like if Python scripts alone are not enough anymore, and you want to actually make it more beautiful, you can expose your the results of your Python scripts to, well, a new front end with some data views, some automated completely automated reporting, live data, whatever you want. Well, it's all possible. There are no limits there, so you can go as far as you want. Stuff that would definitely not be possible back with the old Excel file. So that's well, the use case for reports. Another well, buzzword that I hear very frequently are ETL pipelines. ETL stands for extract, transform, load. So basically the idea is you extract data from an external source. So let's say a different company or publicly available data. In the case of our coffee, we might want, well, we might buy our coffee from some lady in Colombia. And well, we have our own records of what we bought, but she has her own records, and they might differ, you never know. So we might want to well, ask her for an API key so that we can get her data. Of course, she has stored it in her own database, completely different from our database. So then we have to transform the data so that it can be compared to our own data. Probably some calculations are needed, whatever. And finally, we can load it into our own database and compare it to our own records. Well, exactly what we want. That's basically the function of an ETL pipeline. So make data usable for ourselves, and in the end, store it in the backend. That's that. Finally, in the context of data processing, the last slide, there's more, a lot more. I mean, there's been a lot of talk about data engineering, but well, there are a lot of very specialized calculations. I, for example, have worked for a company that, well, normally was in the engineering field and wanted to make designs, and they have like, well, do structural calculations for say a bridge. Let's say a bridge, and they have specialized software. You can model a bridge, and you can put some loads on it, and you can calculate if the bridge breaks or not. But that modeling, well, takes a lot of effort, takes a lot of time, and traditionally they would make like 3 or 4 models of the bridge and pick the one that performs best in the end, and then they will go ahead and build that bridge. With Python scripts, you can, well, automate this modeling process, and you can easily make, instead of 3 or 4, you can make 3,000 or 400 models, 3,000 or 4,000, and you can run them all during the night when the rest is sleeping. And in the morning, you have not 3 or 4 designs to pick from, but 4,000. And well, you can arguably have a better informed idea about which bridge to build. Well, there are other things. There are simulations, optimizations. Well, suppose we don't want to make all our 4,000 designs, but we want to like apply a smart optimization algorithm to find the ideal design. That is very much possible using SciPy as a Python library, and of course, very much hyped. Machine learning has also been done quite frequently using Python. TensorFlow is a much used framework there that will make sure that you can use your GPU instead of the CPU and make everything go faster. So yeah, there's a lot of stuff that you can do with it, and that is very much fun, if you ask me. So then the question is like, well, why would you do all this in Python instead of well, Java or C or C# or well, PHP, to name something? There are tens, hundreds, thousands of backend programming languages. And well, what do they say? They say, well, as often said, Python is sort of executable pseudocode. I put a little example here on the top, and you can see, well, it's very easy, although this is already like, we have a list here, we have a for loop, and we have an if statement. And the syntax is very simplified, like anything that's unnecessary, any brackets, anything is left out to make it, well, as quickly readable as possible. And yeah, that leads to well, rapid development, rapid prototyping. And well, on the one hand, I think everybody here knows developer hours are quite expensive. So if you can develop an application faster, makes it cheaper, makes it better from a business perspective. But on the other hand, also, well, rapid develop or easy development and easy syntax enables, for example, scientists or engineers to write their own well, scripts or simple applications for data processing, as I've mentioned before. So that enables like all this like wider application of your well, of your code, and leads to, well, the next advantage with it, which is like a very wide field of application. Like you have your backend, you have, well, your frameworks for databases, like really IT specific applications, but on the other hand also, well, NumPy, SciPy for complicated calculations, Pandas for reporting, machine learning. There are tons of libraries available for any of those. So I think those are the most important advantages of Python. And of course, there are also some disadvantages that I'll want to mention. First of all, it's not compiled. So that means, yeah, every time a computer gets to a line of your code, it will quickly translate it to ones and zeros before executing it. And that, well, of course, is quite slow. I think I've heard in the past, I've never tried this myself, but I've heard in the past that Python is about 40 times slower than C for comparable logic. So that's definitely significant. One other disadvantage of this is also that if you don't compile your code, so if you plan to not have a web application, but for example, ship some piece of software using a traditional CD or whatever to your clients, if you have any intellectual property on there, the code bases will still be readable to them. So any intellectual property that's in there will be gone, basically. So you have to, well, be careful about that. One more thing that I've heard, well, more specifically, well, older software developers complain about is that it's not type safe, which, well, they say that it encourages bad practices and bad programming, where I think they have a point. But for all this, well, disadvantages, there are important workarounds. And well, to start with the slowness, the performance, Python itself is a program written in C, and there's quite an easy interface to C as well. So if you want to have a calculation or an algorithm that needs to be done extremely fast, you write it in C, you call that function from Python, and in the end, you have, like, for most of your code, you still have your easy Python code with a performance of C for the complicated calculations. So that's, well, very well. That's, by the way, also how all of the libraries, professional libraries work. So NumPy and SciPy and Pandas as well. They internally are written in C and only have an interface to Python, so that well, the performance is very good, but still it's very usable. Then there are options like Cython, for example, and I think there are a few more, although I lost the names of them. That is basically something in between Python and C. So it's Python. The goal of it is to compile your code and be able to ship it to clients, for example. So you write Python, it gets compiled, and then you ship it. Also improves performance, although slightly less than running it straight in C. Then there are libraries like MyPy, which enforces types in Python. So Python by itself supports type hints, but they're not going to be enforced. So you can say, okay, this variable is a list, and then you go and put a string in there, and Python will be fine. But MyPy will read those types, and if it's not what it says it is, then it will actually break. So that way you can create a type-safe application as well. So I think with all this, well, workarounds and all the advantages of Python itself, it's a very good alternative to well, to use it for web development, data engineering, normal engineering, or well, normal traditional engineering, whatever you want. I think it's a good alternative. So that's that was my part. Are there any questions?
Let's see. Oh, so questions are coming in. Do you recommend Golang for data science?
I have never used it actually. So I dare to say very little about it. Although what I heard is that it's yes, that it's very interesting, especially because it is compiled. So that it can be very well used, although since it's quite new, I would be wondering about frameworks and libraries, but that's yeah, like I said, I don't know. I've never used it.
All right. There's another question from Tom Lee coming in. How do you verify the quality of your data?
Yeah, that depends very much on well, where your data coming from. What can I say? Can this be a bit more specified in like what context? What?
Maybe I don't see a follow-up question, but maybe regarding the ETL.
Yeah, what I usually in the developments that I've been part of up until now, it's usually well. First of all, most of the ETL pipelines that I've been working with were developed by, well, experts in their specific field. So let's say in this case, it was a financial expert who has been working with, well, with the exports from, well, the system that was coming from for years and years. And so they had very, very good knowledge of like what type of data we could expect, and then of course like we can like while importing it, while transforming it, you get every row of data you get through your Python code. So then you can well, do some type checks, do some format checks as well, and change everything. So that's basically the way we try to make it usable for us.
Right. So shouldn't it be called ETCL instead of ETL, where the C stands for cleaning?
Yeah, I guess that's a very good point. I guess it strongly depends on your application, on how much you trust your external data source. In the cases that I've been working on, the external source was quite well trusted, often even in the same company. So in that case, the cleaning was a minor part of the transformation. So in that case, it was ETL. I can imagine that in a lot of other cases, the cleaning is quite important. Yeah, I guess it comes down to while Googling during the term that I heard most was ETL. So that's the one that I try to stick to.
All right. So what are the sources you use data from? A question from Amelie.
That can be can be APIs from external companies. So, let's say from a client who have or a company where we are client from, an API that they publish to us that we can access. So that way, we would be basically a client to their API. Can also be, in a simple case, just an Excel file. So somebody has an Excel file with thousands and thousands of records of whatever, and you load it into Pandas, and you do, in that case, you do a bit more cleaning. So those are, I think, the most or the cases that I've most seen. I've also seen old records that used to be just on paper, real old school, that they wanted to digitalize. So then, you get scans and you get some text reading. I wasn't involved in that part. And they wanted to get everything into the electronic database. So that's a different data source. And I'm sure that there can be lots and lots of different more data sources. Can be anything.
All right. Other questions from the group?
Wait.
Is the graph data model comparable with the star model?
What's the star model? To be honest, I've haven't heard that name yet.
Let's see if Dennis can aid you with that.
I was muted. It refers like the time, like all of these different timestamps. The data's like time bound, such kind of stuff. I actually don't know out of my head what actually these dimensions are. It refers to like a time dimension, and there are all kinds of dimensions.
I do indeed think that, this, let's say I recognize this. For example, in the graph model, one example that is very often used is like you have a user and you have a number of messages, and then on the edges to the messages, like you have a user as a node and the messages as a node, and on the edges you have like timestamps from like did it receive the message, or did it send the message, like all kinds of metadata of the that are on the edges. So I guess in that sense it can be in some way related.
Yeah, indeed.
That's,
all right. I don't see a lot of other questions coming in from the group right now.
Yeah, I do have a question for you, Alexander. When do you start selling Spielberg coffee?
Well, we already do, but you can get it for free at our offices. What you should do is contact either Tommy Lee, Rosemary Franke, Joris Rita, Mark Lefever, myself, to grab a free cup of coffee and have a nice chat regarding your availability or your wishes on the development spectrum.
Nice. Best coffee, free coffee.
I've heard it's the best coffee you ever have, but you should come by and see for yourself.
Yeah, definitely will. Cool.
All right. If there aren't any more questions, I would like to thank you all for joining us this evening. and for telling us more regarding design systems and Python development. I would love to see you all another time soon. Maybe next time in person again. But for now, best wishes for the rest of the year.
Best wishes to all.
All right. Merry Christmas and so on, I guess.
Good night.
Good night.
We'll be in touch. If there are any more questions, you can send them via the link you've used on meetup.com, and you can well, I will repost the questions on the answers of Dennis and Erik. All right. Good evening.
Good evening, guys. Bye.
Good evening.